In this lesson, we're going to be looking at the real number system, or it can be called the classification of numbers. We actually looked at this previously in the school year, but we're going to look at it in a little more detail this time. So this may be review. The classification of numbers is where we're going to have some concentric circles here. And in the center, we're going to have a group of numbers called natural numbers. So if you're taking notes, write natural numbers in the center. Natural numbers can also be called counting numbers. You can hear it both ways. And these numbers is like if you were in kindergarten and they said, boys and girls, let's start counting to 10. You would probably say 1, 2, 3, 4, 5. Most people, when they're counting, they do not start on 0. So counting numbers or natural numbers are numbers that start with 1 and go up by whole numbers, 1, 2, 3, 4, indefinitely. The next group of numbers, which includes all natural or counting numbers, are the whole numbers. Whole numbers are all of the natural or counting numbers and one more number, which is 0. So the only difference between these two groups of numbers is the number 0. So normally we just start with whole numbers and we kind of ignore this because the groups are almost identical. But there is a difference between them, so it's good to see that. So whole numbers are starting with 0, counting up with numbers. There are no fractions, there are no decimals, it's just the whole numbers, and there are no negatives. The next group of numbers, which is going to include, and that's why our circle is around them, it includes all the natural numbers, it includes all the whole numbers, and now we're going to add all of the negative whole numbers. So integers are all counting and whole numbers, and what we're going to add is what we call their opposites, which means the negatives for those same numbers. So for example, this would be, if I were counting, starting at -5, it'd be -5, -4, -3, -2, -1, 0, 1, 2. So on your notes, you'll want to write all the things that you're seeing up here on the screen. So integers are whole numbers and their opposites. The next group of numbers that we have includes everything before. That's why the circle is encompassing all of those other groups. It's all whole numbers, all integers, and now we're going to add something called fractions and repeating and terminating decimals. And these are rational numbers. Rational numbers include the integers and the whole numbers, but they also include the fractions and repeating and terminating decimals, such as fractions as 1/2. 25 hundredths is a terminating decimal. 67 hundredths a terminating decimal. Back one more slide. This would also include repeating decimals, such as 3/10 repeating, or 2300, or that's 23/99 repeating. Now, the group that we didn't really talk about earlier in the year a whole lot about is the irrational numbers. Now, if you see, I don't even have this in the concentric circles. It's over here all by itself because it's a group of numbers that does not have anything in common with everything else. These are numbers that cannot be expressed as a terminating or repeating decimals. They are called irrational numbers. Irrational numbers are going to be numbers that are decimals that go on and on forever. Do not terminate, do not repeat. Such as pi. We have learned about pi, and that decimal goes on for infinity, so that is an irrational number. Now, when you take the square root of numbers that are not perfect squares, so if I were to type into my calculator the square root of 5, you would see a decimal that continues on and on. The square root of 3. So if you're taking the square root of a number that's not a perfect square, now the square root of 16 is a perfect square. The square root of 16 is 4. So that's not an irrational number. It has to be one that's not a perfect square. And that's what we're going to be looking at this chapter a lot. So let's look up here. We're going to see if we can name all the sets of numbers to which each real number belongs. We're going to put a W if it's a whole number, I for integers, R for rational numbers, and IR for irrational numbers. Now, remember that the whole numbers and encompassing that are the integers, and around that are the rational numbers, were. If you find which circle your number is in and then work your way out, you can name all the sets of which it is a part. For example, 33. 33 you would think of as a whole number. So it's a whole number, but it's also, if you work your way out, also an integer, also a rational number. It is all three. So I put were, whole, integer, and rational. Here is a decimal that you see as repeating. It's 58 repeating, 58. It repeats. That is a rational number. So we find where it is and work our way out. Well, that's the outer circle. There's nowhere to work out to, so that's just a rational number. Negative 51 is an integer. So if I work my way out, it's an integer and a rational number. Negative 4/6 is the fraction. That is a rational number. It's the outer circle, so it's just a rational number. The square root of 17. This is not a perfect square. So this is the square root of a number, and when you type it into your calculator, you will see that it is a decimal that continues on and on. So that's our irrational number. And here is a terminating decimal, so that is a rational number. So let's compare the following numbers. If you have the square root of 7 and you're comparing it to 2 and 75/100ths, probably the best way would be learn to type in to take the square root of 7 on your calculator. And when you do, it's going to be a decimal that never ends, but all we need to do is be able to compare it to the 75/100ths. So when I type in and I look at the first, it says 2 and 6, 4, and then it continues on, 5, 7, on and on and on. But all I need to do is look at right here and compare the 6 to the 7, and we'll see that the square root of 7 is less than that. So I will put a less than symbol. When comparing negative the square root of 50, 50 is not a perfect square. So if I type in the square root of 50, I'm going to get a decimal that says 7.07, and it goes on and on and on, and it's negative, and this is a negative 7.000. Now remember, negatives, what appears largest is actually the smallest. So over here we have the 7 in the hundredth spot compared to the 0 in the hundredth spot here. That appears larger, but because it's negative, that one would actually be smaller. Next, we have 3 2/10, comparing it to the square root of 15. And if I type the square root of 15 into my calculator, I will see that it's 3 and 87/100ths, and it continues on and on and on and on. But that's enough for us to compare the 2 to the 8. The 8 is larger. So again, this is a less than symbol. Let's look at these and see if we can order them from least to greatest. When writing your answer, write the numbers in their original form. Well, we have two decimals, and then we have the square root of 10. So we'll have to type in the square root of 10, and I look at my calculator and I see it's 3.16, and then it continues on and on. But that's enough for me to compare these numbers and write them from least to greatest. We have a 1 in the tens column, an 8 in the tens column, and a 7 in the tens column. So from least to greatest, I would write the square root of 10, and then 3 and 75/100ths, and 3 and 8/10ths. For the next group of numbers, again, we have the square root of 46 that we're going to have to figure out what it is. So when I type in the square root of 46, I have 6 and 78/100ths, and then goes on and on and on and on, because it's an irrational number, but that's enough to compare. Now these are negative, so what appears larger is actually the smallest. So our negative 7 would be the smallest, and the next would be the square root of negative, the opposite of the square root of 46, and then we have negative 6 and 2/10. Now this is probably the most important part of the lesson, because this is going to take us into our study about triangles. When you are trying to solve for r here, it says r squared equals 67, and we want to solve for r. Well, r is being squared. And the opposite of squaring is taking the square root. So in order to solve for r, we have to do the opposite operation, which means we're going to take the square root of both sides. Well, the square root of r squared is just r. So the square root and the square cancel each other out. I have r. So to solve this, I have to take the square root of 67. So when I type into my calculator the square root of 67, I get 8, and then 1, 8, and then it goes on and on and on. Now, here's the thing that's the most important to hear. When taking the square root of a number, the answer could be either positive or negative. Why is that so? I'm going to shut this very fast. Okay? Let's just back up for a minute. Let's take a number that is a perfect square. Let's say you're taking the square root of 16. Well, the square root of 16 is 4, because 4 times 4 equals 16. But it is also true that negative 4 times negative 4 is a positive 16. So the solution could either be positive 4 or a negative 4. So when we take the square root of 67, we say plus, it could be a positive 8 2/10, and I'm rounding here, this is rounded to the nearest tenth, or a negative 8 2/10. In other words, 8 2/10 times 8 2/10, these are rounded, so it's not going to be exactly 67, could be the square root of 67, or a negative 8 1/10 times a negative 8 1/10. So what you will see is plus or minus. It could be either one when taking the square root. So if we're taking t squared equals 2 6/10, again, to get t by itself, you have to do the opposite operation. T is being squared, so we're going to take the square root. Those cancel out, and I have t. When I take the square root of 2 6/10, I type it into my calculator, and we're going to have to round because this is an irrational number, which means the decimal goes on forever. So I'm going to round it to the nearest tenth, which is 1 6/10. It could be a positive 1 6/10 times a positive 1 6/10, or a negative 1 6/10 times a negative. So what we say is it is either a positive or negative 1 6/10. S squared equals 298, the same thing. In order to get s by itself, we have to take the square root of both sides. Now, again, when we type that into our calculator, it's going to be an irrational number, which means a decimal that goes on and on forever. So we're going to round to the nearest tenth, which would be 17 3/10. But it could be either a positive or a negative 17 3/10. So make sure today when you're doing your assignment, if you're taking the square root of a number, you have to indicate that it could be positive or a negative. So you write the plus or minus of that number. And that is the classification of numbers.